Hello grade 11s, let's have some fun today. Let's start with Newton's first law of motion. Now, this is not going to be so much a definition that you're going to apply using problems. It could be more a theoretical kind of question, but we will be looking at that. Alright, so what is Newton's first law? Let's have a look. And this is exactly how it's standing on your exam guidelines, so make sure you know that. Alright, so Newton's first law of motion states that a body will remain in a state of rest or of movement with a constant velocity unless a non-zero net force or resultant force acts on it. Okay, so what does it mean? It means basically, if we look at motion, it states three kinds of motions. Number one, it states that a body is moving at a constant velocity. Okay, constant velocity or a constant speed. That means Newton's first law is in play. So that means that that object will keep on moving at a constant speed or velocity unless an external force acts upon it. So if there's nothing else, let's just imagine an ice skate rink. You're on an ice skate rink and I do give you a little bit of a push on that ice. You're going to be starting to slide at a constant velocity unless what? Of course you hit the sides of the ice skating rink. So that would then be your external force. Now it started already with Galileo that said if I would have an object, I would have a slope like this and I would have a ball that runs down that slope. And if that ball starts to move and run down the slope, and if there is no friction, no external resultant non-zero force, no other forces acting on it, it will just keep on running with that constant speed and never stop. Okay, so the first thing that we're looking at with Newton's first law is where it states, let me just get my, okay, is this movement. The movement is at constant, so it's a constant velocity. Or it could mean that object is standing still. So it's stationary. It doesn't move. Then it also means that it will stay standing still, of course, unless an external non-zero force or a resultant force acts on it. So you're standing there still, not moving, here I come and I give you a slap, yes, then you're going to start moving. But unless that happens, you're going to keep on standing still. So that is Newton's first law. So what does it mean? It means there is no acceleration. Alright? No acceleration. So basically, if I look at these three things, I could say, okay, then this means that object is in equilibrium. If I would draw a free body diagram of all the forces acting on that object, there will either be none or they will be in equilibrium, which means that I would then could say that the net force operating on it equals 0 Newton. Or it will cancel each other out, or it will be 0 Newton. So that's Newton's first law if I would write it as a formula. F net, F resultant, the resultant force equals 0. A body will keep on standing still or moving with a constant velocity unless a non-zero resultant force acts on it. So that's Newton's first law. Now let's look at a few examples where we're going to be seeing that. Okay, so I've got two basic experiments I want to show you. I'm sure you've done that in the class already, but let me just quickly show you. The first one is just going to be this one. So you're going to see immediately that this law of Newton is going to link up with inertia. I'm sure you've heard of the word already. So what is inertia? Inertia is the property of a body which causes it to doesn't want to change. So it resists any change. In this, it's going to want to stay. If it is in rest, it's going to wanting to stay in rest. If it's already moving, it's going to want to keep on moving, which is Newton's first law. Okay? So if I look at this, and I just have something on top of a little carton here, I'm going to place it there, and if I now would go and just pull it out quickly, the object falls in. Why? I've pulled the object out, or the paper out. Here's the paper in my hand, although the object fell in the glass. Why is that? It's because the object has a property that causes it to resist any change in motion. So it was in rest, it was standing still, and even though the paper started to move from beneath it, it didn't want to move immediately, so it had inertia to movement. It didn't want to act. If, however, I would pull this out too slow, yes, then the object would start to move with the paper. So the whole thing of inertia, it is when it's happening quick. So that paper is moving, this one has got inertia, it doesn't want to move. So before it even starts to realize, listen, the paper has moved from underneath you, you better start moving with it. It's too late and it falls in the bottom. Now, I'm sure you've seen a few comedy shows already where they did this. So I'm just going to use something that is unbreakable. I've seen it, of course, they do it with a whole setup of plates and knives and glasses and the whole titty. But let's just look at this one. So this is something you can try at home, okay? And show your parents, all right. So if that is true, inertia is existing, then of course this object is also not going to want to move. So let's see if that's true. And yes. So you can actually pull out something from beneath a whole setting where your mother put out, knives and cutlery and whatever. You could actually pull the tablecloth from under it, okay? But now there's a trick to it. The trick is inertia is directly proportional to mass. So the heavier an object is, the more inertia it is, the more it has this where it is resisting any change in motion. So if it's something light, it will easily start to move. If it's something heavy, it's going to really resist any change in movement. So inertia, directly proportional. So if you do this at home, guys, please use something firstly unbreakable to practice with, and then use something that is a bit more heavy, okay? Then you're going to be able to pull it off. So this is what we call inertia. Now another case where they want us to concentrate on is of course seat belts. So if you are sitting in a car, and the car, your dad is driving on the highway at, let's say, 120 kilometers per hour. That means that your body is also moving at 120 kilometers per hour. Now you've got inertia too, which means your body wants to keep moving. If there is a sudden stop, what happens? You're going to go forward and you're going to hit the windscreen and probably go straight through because the car stops, but your body is going to want to keep on moving, which is a typical example of Newton's first law. Unless an external non-zero force acts upon it. So what could that be? Of course, the seat belt. If you've got the seat belt on, the seat belt is going to pull you back in the opposite direction, and that will cause you to then also stop or coming to a standstill. So you won't be flying straight through the windscreen. It's the same effect that if your dad goes around a bend in the road, your body still wants to keep on moving in that direction, although the car's already going that way. So that's a typical thing that we have where we fall to one side or fall to another side, and that has to do with what? Newton's first. So guys, again, this question is very much going to come up with either they're going to ask you directly for the definition, or they could ask you, let's say a question like this. Let's have a look at how can they ask like a secondary theoretical question. So it's a theoretical question, but it's not straightforward a definition. So we call that like a level 2 question. So the question could be that you have a rope, and on the rope you have an object and a little rope again tied to it at the bottom. So you've got two of them. Alright, and then we're going to say on this one, so let's call that T1, and tension in the cable T2, so that's the tension in the cable on the top, tension in the cable at the bottom. Now let's say they say you start pulling on this rope here, but you pull slowly. Which one is going to break first? T1 or T2? You pull slowly. Yes, you're going to break T1 first. Why? Newton's first law that says this object will stay still unless a net force acts upon it. So it's got inertia. But if I pull slowly, like I've showed it to you previously with that object that fell into the bottom, into the bottle, if I pull slowly, then this mass is going to start going down with me. Then I've got my force pulling down, and we've got the weight of the object pulling down, and that means it's going to break there. But what is going to happen if I pull, or this T2 quick, so I give it a quick pull, alright, a quick force acting onto it? Where is it going to break now? Now it's going to break here at T2. Why? Because yes, I've got an applied force, me, pulling onto it, but very quick movement. But then the weight, because it is not moving with me, it wants to keep on standing still. It's going to just be working against me. And so then the main force is going to be on this one, and it's going to break here, not there. So that is a typical question where they could say to you, explain or which of Newton's laws, because you're going to see we're going to do 3 laws, Newton 1, 2 and 3, was used. So Newton's first law says F net equals 0 Newton. That object is in equilibrium, he wants to stay in equilibrium. Alright guys, so that's it. Newton's first law, and learn that formula or that definition by heart. You can do this. Believe in yourself.